Hi there and welcome. My name is Shahab and I am your physics mentor and I'm the faculty at askIITians.com. Today we are going to study a very important and extremely interesting topic of 11th standard from the chapter Fluid Mechanics, and that is Bernoulli's theorem. You know, this theorem was given by a scientist Bernoulli, and there were 100 Bernoullis in his family, and all of them were genius, all of them were great scientists. So one Bernoulli was there, Daniel Bernoulli, and he gave a famous theorem which is called as Bernoulli's theorem, and which brought a revolution in the field of physics. So this is really very interesting topic. So without wasting any time further, let's start the topic. Okay, so let's have a look at the syllabus of 11th standard. Fine. So we have first chapter, which is physical world and the measurement, where we will discuss the importance of physics, how was the development in the physics made earlier and how we are improving nowadays. Similarly, we have second chapter called kinematics, where we study a lot about motion, and then we have the laws which govern the motion. Then we have work, energy and power, how work and energy and power, they are related to each other. And so after that we have motion of system of particles, or some author says that system of particles only, or you may call it rotational mechanics, so it's same thing. Then you have properties of bulk matter. In this chapter particularly, we study about fluid mechanics, and from this chapter, the bulk properties of matter, we are going to see a fluid mechanics topic, and from this topic we have Bernoulli's theorem. Okay, then we have thermodynamics, all about heat, how heat flows, how heat exchanges between the medium and the surrounding, how the steam engine was developed using the laws of thermodynamics. Similarly, after that we have kinetic theory of gases. We will learn a lot about gases, the pressure of gas, the temperature of gas, how the volume of gas is affected, and so on. And then we have oscillations and waves, how sound is created, how sound travels, and how the frequency affects the sound quality, and so on, and other things. Okay, so let's start the Bernoulli's theorem. So this is the scientist Daniel Bernoulli. He gave this famous theorem, Bernoulli's theorem. Okay, and what he said, I'll discuss it later on, but I'll tell you the phenomena or the technology we have developed using Bernoulli's theorem. For example, you see the aeroplane, they fly using the Bernoulli's theorem also. The flying of an aeroplane we can explain using the Bernoulli's theorem. That means by using this theorem, Bernoulli's theorem, we have developed our technology, and we designed the aeroplane so that it can fly, it can lift, and it can fly at higher altitude. Okay. Similarly, the second example we have is a very simple example of atomizer, or what you call a spray device. You know what is interesting? Did you ever try drinking juice with a straw? The interesting thing is the straw works on the same principle of physics, that is called Bernoulli's theorem, and on the same principle the aeroplane flies. Okay. Similarly, on the same principle we have this atomizer, what we called a spray device. You know, on the same principle, Bernoulli's theorem only, we explained the movement or the sailing of a ship in an ocean. This can also be explained by Bernoulli's theorem. Did you ever think we have no steering? In the olden days, we didn't have any steering on the boat, but we would have been able to control the direction of the ship. How come? Explained by Bernoulli's theorem. Similarly, we have MAGNUS effect. Now, what is this effect? This effect is about if you have a ball, whether small or big, if it is spinning about its own axis, then this spins causes a pressure difference about it, and that pressure difference pushes this ball, and that causes a deflection in its motion, and this deflection is called Magnus effect, and this can also be explained by Bernoulli's theorem. Okay, so you know how interesting is this topic, yes or no? Okay, so because we know this, so let's see what actually Bernoulli says, then we will come to the explanation of these. Okay, so here is what Bernoulli says. It says that if a fluid is in motion, now what is fluid? A fluid is something which can flow. So it can be either a liquid or it can be gas. So we consider liquid and gas as a fluid. So this law is actually, or this principle is actually valid for a fluid. Now it says if a fluid is in motion, then at a particular point, the sum of the pressure plus rho gh, where rho is the density of the fluid, g is the acceleration due to gravity, and h is height of that point where you are interested in to find the pressure from a certain level. So that is the height from a reference level, plus half rho v square. Rho is the density, v is the velocity. So it's actually, I don't go in detail, but I'll tell you that P is actually pressure energy density, and rho is actually gravitational potential energy density, and half rho v square is actually kinetic energy density. So the sum of all energy density at a particular point in a fluid remains constant. Let me repeat it. The sum of pressure energy density, potential energy density, and kinetic energy density for a fluid at a particular point remains constant. So this means that this principle is based on a very fundamental principle of physics, and that is conservation of energy. So this principle is based on conservation of energy. Okay, fine. So let's have a look at this. That's how I showed it. There is a blue line, you may call it a reference level, and the fluid is in motion. So at a particular point where I'm interested in, the height of that point I have taken as h, you can see here, right? And then at that point, suppose the pressure is P and the fluid velocity, let's say it is air or water, whatever, its velocity is v and it is at the height h. So according to Bernoulli's principle, the sum of these three quantities, the pressure, half rho v square and rho gh, should be constant. But here, if we keep h constant and we keep focusing, if we change the velocity at this point, what would affect, how it would affect the pressure. So at particular point we are talking about. So if height is constant, then rho gh is also constant. So we can say a more simplified form of Bernoulli's theorem or principle, it becomes sum of pressure plus half rho v square equal to constant. Now this indicates that at any particular point, if the pressure is more, fluid velocity is less, because the sum has to be constant. So if the fluid is moving faster at some place, the pressure will be higher at that place. Let me repeat it. If the fluid is moving faster, the pressure will be lower. So if air is flowing in certain direction, so if the air velocity is more at certain point, then at that point pressure will be low. Now please understand, so whenever there is a pressure difference, a force always acts from higher pressure to lower pressure. So please understand, if the fluid velocity changes, it will change the pressure. If fluid velocity is more, pressure will be less. If the fluid velocity is less, the pressure would be more. Is that okay? Clear? Now let me explain all this with a phenomena. I want to show you first of all the first phenomena, the flying of an aeroplane. Look at this. You see here we have the aeroplane wings. This is how the wings are designed. So it goes like this. See, so the air above the wing moves faster because they have to meet the air above the wings and the air below the wings. They have to meet simultaneously at the same point on other side. This is the reason the air above the wings has to cover more relative distance. So the velocity becomes faster. The velocity of air becomes faster above the wings because it has to cover relatively more distance. But the air molecules just below the wings, they have to cover relatively less distance. So the air molecules or the air is moving slower just below the wings. So the fluid velocity is low here, just below the wings, and so the pressure is more just below the wings. And just above the wings, the pressure is less because fluid velocity is more. So from high to low pressure, a force acts on the wings in upward direction, and that force we called lift. So this difference between the pressure at the top and underside of the wing causes a net upward force, what we called a lift, which helps the plane to take off. So if the wings would flat like this, we would not be able to take off the plane. I hope you understand it. So please understand, if you simplify the Bernoulli's theorem, you can simply say that this theorem tells us if the fluid is moving faster, it decreases the pressure there. If the fluid is moving slower, it increases the pressure there. Let's have another example here. Here, what we do, when we squeeze the button connected to the atomizer, we actually moves the air faster. So at the top, where the air is moving faster, the pressure becomes low. And at the bottom, inside of the atomizer, there is still high pressure because the fluids are almost at rest. The air inside the atomizer is almost at rest. So the pressure is very, very high inside. And at the above, the pressure is very low. So this pressure difference causes a force from the bottom to the top. And that's how you see the spray comes up and it spreads out. We have another example, this. So you can understand the wind through this side, the wind speed is faster, and through this side, wind speed is slower. So from high pressure to low pressure, there is a force acting that keeps the direction changing. So you have to apply a force on the cloth you are using, or what you say is this is the reason you can see here how the boat sails around in the ocean. So this is what we call, it helps us in controlling the direction of the ship. I want to explain one more thing, okay? And let me explain that with an example, with a video I want to share with you guys, okay? Just hold on. Okay, let's discuss about this Magnus effect, how a spinning ball changes its direction. This is important for us, okay? So here you can see the ball is spinning about its own axis. It is rotating about its own axis, and the wind is moving from left to right. So you see the lower portion, the air molecules or the wind just below the ball is moving relatively at low speed because it has to cover relatively less distance, because the clockwise direction helps to decrease the speed of the wind. So the wind is flowing slower here just below the ball, so the pressure is high just below the ball, and just above the ball you can see the wind has to cover relatively high more distance, so its velocity increases just above the ball, and that increase in the velocity causes the decrease in the pressure. So now again there is a pressure difference. Below the ball the pressure is more, and above the ball the pressure is very less. So a force acts from the higher pressure to lower pressure, and it acts in upward direction, and this causes the ball to deflect in the upward direction. See, and here I have shown an example here. This is actually the radio wave image. Then we have developed it with technology. This is how an air goes around certain objects. You can see just above it the air molecules moving faster, and just below this air molecules moving slower, and this object is rotating in clockwise direction. So you can see here this is the picture of a flow of circular rotating cylinder. So if the cylinder is rotating clockwise, the air molecules above it moving faster and below it moving slower. So the pressure is low at the bottom and the pressure is high at the bottom and low at the top, and this is how a force acts in upward direction. Okay, now look at this video and enjoy it. Okay, let me show you that. Now you have another example. Here a ball is spinning about its own axis. So as I explained earlier, a spinning of ball causes a pressure difference. Okay, and this pressure difference deflects the ball. Now look at the motion of the ball. Here it goes, it deflects away from you because of the force due to the pressure difference. You can see it goes away from you, right? Okay guys, so I believe that you understand, you enjoy the topic today. Take care then. Thank you so much.